Okay, back in 11.3 we learned what the inverse variation graph looks like. And today we're going to add to our rational function knowledge by looking at functions that are of the form a polynomial divided by a polynomial. And we're just going to learn today how to graph the rational functions where the numerators and denominators are first degree polynomials. We're not going to take it any more or any further than that. So these are the simplest of a polynomial divided by a polynomial. So the first thing to understand is the form. So every rational function that we're going to do in Algebra 1 is going to have this form y equals a over x minus h plus k. This is going to be the graph of a hyperbola. And the hyperbola is going to have a center of hk. So in this case, what we're talking about when we say the center, you'll notice we have dotted lines, vertical and horizontal, in this graph. Now, as you recall before, dotted lines are usually there not as part of the graph, but just as a guide in the graph. And that is certainly the case when we're graphing a hyperbola. So the steps to graphing a hyperbola are going to be to identify where these dotted lines are, which are called asymptotes, and put them on the graph. And then you're going to graph either in the upper right, lower left quadrant or the upper left, lower right quadrant. That's how the hyperbolas work. So those vertical and horizontal lines are the asymptotes, and the graphs of the hyperbola are going to have lines that are going to approach the asymptotes and never actually touch them. And it's one of those magical things that happens. You can see that we're coming from negative infinity. As we're looking at the graph from negative infinity on the left, we're coming in and we're going to come down and we're going to get to about, it looks like about the number 5 for x, and then we're going to go downward to negative infinity, and then boom, other side of the 5, we're coming back down from positive infinity. So there's this like magical thing that's happening at the asymptotes. The distance between the line or the graph and the asymptote gets smaller and smaller, but again, the graph will never touch the asymptotes. So here's the first of the problems that we're gonna graph. So it's already in a great form for us. This is in the form y equals a over x minus h plus k, and we're asked to graph and describe the domain. So the first step to graphing is to find the center. The second step is going to be to put the asymptotes in, and then we're going to plot some points. So the center in this case is negative 2 comma 1. And again, going back and looking at the form, it's negative h plus k. Look at those signs, negative h plus k. And so that's where we get the negative 2 plus 1, because it's in the denominator, it's that negative h. So that's why it's negative 2 instead of positive 2. Once we get that center, negative 2 comma 1, we're going to plot it on the graph, and we're going to put in our asymptotes. So there's our asymptotes are going to go right through that point, negative 2 and positive 1. Then we're going to plot some points. So if I plug in negative 3 in for x, negative 3 plus 2 is negative 1. Negative 1 divided by negative 1 is 1, and 1 plus 1 is 2. So again, all we're doing when we make the t-chart is we're doing some plug and chug. The plug and chug is going to give you an opportunity to see where those graphs go. The center also forms a point that really gives you a mirror image on either side. So every point that's going to be equidistant from the origin or the center of the graph is going to be a mirror image point, and that's our example.